Hey guys, it's David again, and this is Unbound. Today I'm going to be tackling a huge project, one that has been sitting around since February of this year. It's now July, and what we got going on is a blown engine in this 4,000 watt Cummins Onan generator. So basically one day we went to fire this generator up and it just would not start, and it didn't sound normal either. And I tried everything, couldn't get it to work. So Ro ended up taking it in to a Cummins Onan repair shop, and they checked it out and said that it had a broken crank pin. And so that is just catastrophic failure to the engine. And so the only options at that point were to replace the generator completely or to have them replace the engine. And both of those options, they quoted us at around $4,000. And so I was like, no, we're not doing that. We're not doing that. What we're gonna do is I'm either gonna replace the engine myself with a new one, or I'm gonna replace the engine with a used one. I haven't sourced an engine yet, unfortunately, but it looks like I can get a used one for about $800, and I can get a new one for about $1,400. So we're gonna go ahead and get into this project. The first thing I'm gonna do is drain the oil just to see if there are pieces of debris like chunks of metal or something like that to indicate to me that there was indeed some sort of critical failure. Then there are other ways to verify. I'll be checking for compression. And if there's no compression or very little compression, then I know that, yeah, there is a big problem going on and it'll need the engine swapped. So on the underside of these generators, we got this little cap here that covers up the oil drain plug. So we'll just take that off. All right, and that screw seems to be stripped out, so I'll just push this off to the side. All right, we're off to a good start, but there's the oil drain plug. So we'll get that taken off and see if there's anything crazy in this oil. So here's the oil. I didn't see any metal chunks come out of it, and I'm not feeling anything. You know, I was hoping for like a smoking gun right there, a piece of the connecting rod, a piece of the crankshaft, just anything. But no, it's clean. It looks good. It looks normal. It's not like a ton of metal shavings or anything in it. So we're just gonna have to keep diving into this. What I'm gonna do now is take this valve cover off and rotate the fan here, because I believe the fan is directly connected to the crankshaft on these. And so by turning the fan, I think it will rotate the engine over as well. But by having this valve cover off, I can verify that the engine is turning over by I'll be able to see if the valves are moving. Okay, so the valves are moving. You can see the intake valve close and then the exhaust valve close. So yeah, spinning the fan definitely rotates the engine. And I'm not feeling nearly as much resistance as I think I would if the engine was making compression. So I'm gonna pop out the spark plug and just stick a finger up into that spark plug port, plug that up, and then turning the fan, I should feel suction and some pressure, and I don't feel anything. The only resistance I feel is when those springs start to compress. Otherwise, this fan is just freewheeling. So yeah, that piston is definitely not, I don't even think it's moving in there. So yeah, that's a good enough test for me to know that something catastrophic has happened on the inside of this engine to make it not create any compression. So yeah, I think this engine's gonna need to be replaced. Now later on in this project, I'm gonna need a plastic scraper to help clean up the gasket mating surfaces on the intake and the exhaust side of the generator engine. And instead of having to drive into town to the hardware store to purchase a few of those, I decided to just create my own using today's sponsor, Creality, powered by Jackery. Now this plastic scraper with a removable head that I was able to find on Creality's cloud, I think is really cool because, you know, I just printed out this holder and then I printed out a ton of these replacement heads because, you know, they're made out of plastic and eventually the ends will just get destroyed and I'll need to replace it. I also had another really fun 3D printing project that I made for Ro, this rainbow colored vase, which I think is really neat. And right now I'm actually printing her out a little cauldron for a Halloween decoration, since that's her favorite holiday. And all of these projects have been printed out using Creality's Ender-3 V3 Plus, powered by the Jackery Explorer 1000 Plus portable power station. The Jackery Solar Generator 1000 Plus allows you to power your Ender-3 V3 Plus 3D printer in any location, whether you're off-grid, at a DIY market, or during an emergency at home. With a capacity of 1,264 watt hours and an output of 2,000 watts, Jackery's power station supports 99% of devices and can be expanded up to 5 kilowatt hours, providing ample power for extended 3D printing sessions. Jackery's advanced solar technology allows for ultra-fast charging in just 2 hours, ensuring your power supply is ready whenever you need it. The Ender-3 V3 Plus offers high-speed, high-precision 3D printing with a build volume of 300 by 300 by 330 millimeters, making it ideal for a wide range of creative projects. With Jackery's portable power, the Ender-3 V3 Plus can operate in any location, freeing your creativity from the constraints of fixed power sources. Jackery's rugged design and lightweight solar panels, combined with the robust construction of the Ender-3 V3 Plus, make this bundle perfect for creators on the go. Both devices offer intuitive controls and monitoring options, allowing you to manage your power usage and printing tasks with ease. Jackery's Solar Saga 100 watt panels offer up to 24.3% efficiency. They're lightweight, foldable, and IP65 waterproof, ideal for outdoor adventures. And the Jackery 1000 Plus features a long-lasting lithium iron phosphate battery with 4,000 charge cycles, ensuring reliable power over time. Now I find the prospect of being able to literally create your own tools anywhere, anytime, to be very powerful, and also being able to just print out really beautiful decorations. You're only limited by your own imagination with a combo like this. And so, huge thanks to Creality and Jackery for sponsoring this video. Now back to the generator repair. So the decision's been made that I'm gonna have to drop this generator out of here to be able to do the engine swap or do any kind of work that I'm gonna have to do to it. Just gonna start disconnecting all of these electrical connections in here because everything's gonna have to be disconnected from this generator. You know, all wiring, fuel lines, everything from the RV to be able to drop it out and remove it. And don't worry, I took a picture of all of this so that I know exactly where all of these wires go. And next we'll pop the tailpipe off. And then I've got these ground wires run into the corner of the generator. And if possible, I always like to put any nuts or bolts or screws back where they came from, just so I don't have to like mark bags or anything. I don't have to store the hardware in little cups or anything, and I feel like this makes it, you know, harder to lose the hardware too. You don't have to, you know, be as organized. You just have to put it back, and so when I go to put that ground wire back on, the nut's already there. And then lastly, I've got this fuel line. I'm gonna plug it up with a stake, just a camping tent stake. I'm gonna put in that line and then tighten this hose clamp back on. I gotta be pretty quick though, because this line is hooked directly up to the main 40-gallon fuel tank, and it's just gravity fed into the generator. Gotta be quick, otherwise we're gonna gush fuel. Oh. There we go. That should be good. Then we've got this wire conduit coming in to the same side as those ground wires and the fuel line. We'll take this off and see what we got behind it. Okay, looks like we have 3 wires running in. A green one, a black one, and a white one. Then we've got some wires running in through the side of the generator that then run under this, and I believe they run to this switch. And so, gotta take out this electrical board to be able to access those wires, hopefully be able to disconnect them easily, pull those out. All right, I was right. Under those electronics is where those wires connect to. You can see the wires run in here. There's 3, a black, a white, and a green, and they loop around and then connect right here. And so I'm gonna get those disconnected and pulled out. Okay, it looks like the black wire continues on though through this loom, probably up to the starter button. So I can at least get 2 of the 3 disconnected. All right, there's a lot of connections there, but I just want to disconnect the wires coming from the outside, and I'll leave the other ones connected. So this green wire and this white wire, those 2 are disconnected. I'm gonna go ahead and put these wires, or these connections back on, so there's no guesswork later. All right, and here's our black wire running in from the outside. Pull that off, and we can pull this one out too. All right, now we can pull these wires out. All right, we're finally ready to drop the generator, and there's these 2 mounting bolts on all 4 corners of the generator. So I'm gonna go ahead and get those loosened up and then put a floor jack under here to slowly lower it down. All right, now I got a floor jack under there with a board to help distribute the weight. I'm gonna jack this up a little bit, take the pressure off of these mounting bolts, which are all loose now, but not out. And then I'll run those out the rest of the way, and hopefully this thing drops out real easy. The generator's too tall to be able to slide it out. I know on a lot of rigs, they have this whole area like cut off. There's not this skirting around where the generator goes in, so it's easier to get them in and out if you need to. Got quite a bit of height I gotta get over, but I'm hoping that I can just jack the RV up on this side, have enough room to get it out. Let's see. So the floor jack's not gonna work for this. It didn't have enough travel to get the RV up high enough to be able to pull the generator out. So got this 6-ton bottle jack, And I think this is going to be a lot better because not only will it have enough travel now loaded up onto those boards, but it also is going to push the RV straight up as opposed to like pulling it back as the floor jack comes up. And on this gravel, the floor jack can't roll. And so that causes an issue too, you know, jacking vehicles up on gravel or sand. So I think this is going to work out just fine. So it looks like this case is just held on by 4 of these bolts, 2 on this side and 2 on the other side. So we'll pop these off. So my plan of attack is to get the valve cover off, then get the head off, and just kind of look at the valve train. See if maybe a stuck valve or a valve not closing properly is why I'm not getting any compression. So I'm gonna take the valve cover off. Hopefully the bolts for the head behind it are under that valve cover. I'm gonna have to take some of this exhaust stuff off, take some of the intake off to be able to remove that head to get a good look at the valve train. I'm going to start with the intake side, and I'm already noticing a problem. There is one of the nuts that mounts the intake manifold to the head is just buried behind this shroud, this metal shroud. I'm not going to be able to get a wrench to that. It's really hard to even see now, but if I put a light on it, I think you guys can see it. Yeah, that nut is just right in there, buried behind that shroud. So I'm going to have to take the carburetor off first, and then just bring the intake manifold out with the head. And the bolts that mount the carburetor to the intake manifold are behind the air filter. So we'll take this assembly off so we can access those through bolts. Then inside the air filter housing, we've got those 2 bolts that run through the carburetor and mount it to the intake manifold. So we'll pop those off. Now at the carburetor, we need to take these linkages off and disconnect this fuel line so that we can then just pull the carburetor out. Now on top of the head, we've got these 3 bolts holding this shroud on. I'm gonna pop those off because this shroud is also a part of this guy right here that helps regulate the throttle of the generator based on the heat from the exhaust. There's a little heat tube right here that runs down to the exhaust pipe. So we need to be able to get this off so we can pull the head off also. And I noticed this little heat tube is broken right here, so it's probably not really doing its job effectively anyway. We were having trouble trying to get this thing to run at the right RPM, and that could have been part of the issue. Now over to the exhaust side, we've just got these 2 nuts holding the exhaust tube on. All right, well that's frustrating. Looks like the tube goes into the head for some reason. So yeah, I gotta disassemble this exhaust tube a little further up. And now we need to get this plate off that covers the bottom side of the head. So take the spark plug boot and spark plug out. Dang man, those big ones were on there tight. I had to use an extra pipe for more leverage to break those free. All right, all our head bolts are out, so let's see if we can break the head free. Oh yeah, wow, that came out extremely easy, or at least, yeah, wow. That's awesome. Get our push rods out. And wow, look at that piston. That looks awful. Has so much scale on it. That is just, and look at all the buildup at the bottom. Wow. And our cylinder head looks even worse, just all this buildup. Look at all that. And look at this, guys, our intake valve definitely is not seating all the way. Look at that. This is kind of what I thought. I don't know if this, you know, it's not that big of a deal, but it's definitely not seating in there. All right, now for the moment of truth. I'm gonna spin the fan up here and you guys watch this piston. If it moves, then it might be safe to assume that the internals are fine. If it doesn't move, we know that, yeah, there's been a critical failure with the internals of the engine. Here we go. Oh no. No movement at all. I don't think it's coming through on the camera at all, but you can definitely hear some scraping, just some abnormal noises. Yeah, this fan is completely freewheeling. Oh yeah, yep. What? Oh, oh no, you guys. No, that is bad. Oh no. Wow. Oh, oh no. So there's this little ring of carbon buildup at the top of the cylinder wall that is keeping the piston from coming out. The piston rings catch on that carbon buildup. And so I'm just gonna try and scrape it off with this flathead screwdriver and hopefully that piston will pop out, because I'm really curious to see what is going on inside the engine. And I'm not patient enough to wait until I have the entire engine separated from the generator side. And I'm not worried about scratching up and, you know, kind of galling the surface of this cylinder wall, because this whole engine absolutely 100% needs to be replaced. So any damage I do to it doesn't really matter at this point. Oh, oh, come on. Come on. Oh, there we go. Yes. Oh, wow. Oh my, look at that. That connecting rod is cracked right in half. Oh my goodness, and it took out part of the piston there too. Oh my gosh. Wow. That's crazy. Oh. All right, let's see what was going on inside the cylinder. Whoa. That is absolute carnage. Look at that. That is so beat up. And then look at this crankshaft. Look how galled up that is. Wow. There's just so much galling on that crank pin. Wow. I mean, it's really sad that it happened, but it's also, I mean, I don't know, it's kind of fascinating. I think this is so cool. Just the entire surface where the connecting rod connects to that crankshaft is just destroyed. And I'm kind of fascinated by how there's just, it just looks like there's no oil on the majority of this crank pin. Like you can see it just looks completely dry. Like no wonder it failed. Oil, for some reason, oil just wasn't getting, you know, there's oil on this section, but this whole section is completely bone dry. There's not even a film of oil on it. And now I need to begin the process of separating the generator side or the rotor and stator side from the engine. And to be able to do that, I have to start over here and just work my way in so that I can pull all of this off of the engine. Unfortunately, you can't separate the engine from this side of the generator. You have to separate this side from the engine. So I need to get the engine and the rotor stator side of the generator out of this, this tray. And there are mounts here, 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 and here on the underside that I need to loosen. So yeah, I can get everything out of this tray to begin separating it. And to get at this one back here, I have to take this metal brace off right here. There's just 1, 2, 3 bolts it looks like, and then this brace will come off, and then I'll have access to that. And then we have these 2 large mounts in the middle as well. Go ahead and take those off. Then I need to disconnect this electrical connection here from the front left corner because a lot of these, run in through this loom or they connect right here. And so to be able to, get all this separated from this tray, I have to take this off too. There's a ton of star washers too, so just try and keep track of all this with pictures. Thankfully, I'm videotaping all this so I can reference the video, but if you're doing this job yourself, I highly, highly recommend that you take tons of pictures throughout this job so that you just know where everything goes. Oh, shit. It's okay. Perfect. All good? Yeah, thank you. Yeah, no problem. Now I need to get this plastic shroud off, so I'm hoping that taking these screws off of the front, these torque screws, it's gonna loosen this side up. My next step is to get this flywheel slash fan off, and I have a really bad feeling that this is pressed on, but we'll see if we can get it off. Now the bolt on the front of this flywheel is on there super tight, and the only way I can think to get that off is, using a pipe for extra leverage, and then to hold this fan, this flywheel and fan from spinning, I've got this really long board that fits in there, and I'm using wood because I don't want to damage the aluminum fins. Let's see if this will work. Oh my God, yes. Whew. That is really on there. I tried using an electric impact wrench, nut driver, and it just didn't have enough power, but thankfully I was able to get it that way. Wow. So to get this fan slash flywheel off, we have to use a puller, and unfortunately these holes are not tapped from the factory. The service manual states that you have to tap these holes yourself, and so I'm using a 5/16 18 tap. I'm gonna tap these holes then. Wow! Oh my goodness. I knew she just needed a little more heat. Next we need to remove this brush block off of the end bell here. And I know it may be hard to see, but you can see the brushes. There's a brush there, and then there's a brush on this side that I can't quite get the camera to see. But what you need to do, there is a little connector, not this one I'm pulling off. I'm just pulling this one off so I can get to the other one. Yeah, there's this connector right here. And what the service manual says you need to do is pull up on those wires. The other brush is right here. And so you pull up on that and it raises that brush up. There's a hole right here that you stick a wire into while holding those brushes up. And so by pulling up on these brushes, you move them out of the way so you can insert a wire. And then having that wire between the brushes and the slip ring is supposed to protect them during disassembly. And if that didn't make much sense, hopefully this shot right here kind of shows you, you can see that wire, that aluminum wire is directly between the brushes and this slip ring. And now we can take this brush block off. It's just held on by these two screws. also happy to see that there's quite a bit of life left on these brushes. Now we can remove the whole end bell housing here, and we've just got these mounting bolts to take off, and the whole thing should just separate. My end bell doesn't want to just come off, and so I'm just going to gently pry in some spots, try and work it off. Right, this end bell is not coming off as easily as the service manual would make it say, or would make you think that it should. I think it's caught on this bearing or this shaft in the middle, and so trying to work it off evenly with a bunch of screwdrivers. Oh, there we go. Oh, hell yeah. Next step is to get this rotor shaft off, and the service manual says to use a 7 7/8 inches long by 0.45 inches solid rod and stick that into the middle here. And I'm just using a piece of rebar that fits perfectly fine for me. And then to thread in onto the end a 9/16 12 by 1 inch bolt. And I'm thinking this is basically just going to press out that rotor shaft. Oh. And then to remove the stator, I believe it's just these two bolts that we need to take off. And the last thing, to get this housing off, we've got these 4 bolts behind the stator. Now we should be able to separate the engine. Oh, yes! Yes! We did it! But that's it for this video, guys. I hope this was really helpful, showing you how to fully disassemble a Cummins Onan RVQG 4000 watt onboard generator. You know, I noticed that there wasn't any videos out there that showed like a full teardown like this. When I was preparing to do this myself, I, of course, looked on YouTube for a video to help show me how to do this, and I just didn't find anything that showed how to do this full teardown to separate the engine from everything else. And so, I felt it was really important to put this out there, to help anyone else that was trying to do a job like this. But I'm super excited that I was able to get to this point. Honestly, I didn't really know if I was gonna be able to do it. I told Ro that, I'm like 50-50 on whether or not I'm gonna be able to actually separate everything, be able to tear it down this far, and be able to replace this engine. We do have an engine on order, by the way, and it only cost us $1,400 as opposed to $4,400, which is what Roe was quoted by the Onan dealer, just for the generator itself that doesn't include labor to actually, you know, replace it. And so we're saving a ton of money by doing it this way, doing it ourselves, and I'm just really happy. I'm really stoked that I was able to get to this point because yeah, I just didn't know if I was gonna be able to. And I'm not gonna show reassembly. Originally, I was gonna film that too, but I feel like that would just make the video way too long-winded. Because honestly, you know, reassembly is just the reverse of disassembly. And so, I just don't think there's a lot of value in showing that. Also, I think it would just make the video way too long-winded. But thanks so much for watching, guys. I really, really hope this video was helpful to anyone out there looking to, you know, replace the engine on their Onan generator that had a catastrophic failure similar to what happened to us. But my name's David. This is Fate Unbound, and I'll see you guys in the next one. Bye. Thanks again for watching, guys. If this video was helpful for your own generator repair project, then consider tossing me a tip using super thanks below the video player. Or if you regularly watch these videos and you enjoy them, then you know, consider becoming a patron on Patreon. I know that would make Sweetie happy. Wouldn't it, big girl, huh? Oh yeah, that would make you happy.